Let's keep this Megacast rolling. I'm excited to announce our next presenter from Platform9. That is Mr. Bich Lee. He's the co-founder and chief architect. Are you there, Bich?
Yes, can you hear me clearly?
I can. Go ahead, take it away. Thanks for joining us.
Thank you. So welcome, everyone. I'm Bich Lee, Chief Architect at Platform9, and today I'm delighted to tell you about Platform9 Managed Kubernetes, our new container management product, which just GA'd yesterday. So, very excited. And before we begin, I want to give a quick company intro. About 3.5 years ago, three friends and we founded Platform9. We originally came from VMware, so we know quite a lot about virtualization and cloud management, and that's what we do also at Platform9. We're pretty well known for our first major product, which is Managed OpenStack. But today we're going to talk about containers. And so we're going to go over why containers, why Kubernetes, and what can Platform9 add into this space with Platform9 Managed Kubernetes. And I'll finish with a demo. So why containers? I believe that most of you in the audience are familiar with Docker and the mini revolution that has brought to the IT and app development space. Simply put, developers love containers because they make it easy to package an application with all of its dependencies. Then DevOps teams love them because those images can be versioned and they're very easy to deploy in a portable way across a wide range of infrastructures. They're pretty fast compared to traditional virtual machines. But most importantly, application architects and forward-thinking CIOs like containers because they provide a building block for modernizing application design and management. And in particular, what this means is the containers philosophy tends to be break a large application down into smaller components, which can then be arranged in service tiers that are independently scalable and highly available. So that's the philosophy, but one interesting side effect of this philosophy is now you have a lot of moving parts, a lot of containers to manage. So this brings in the need for automation, right? We need frameworks to help orchestrate all those containers. And luckily, we have Kubernetes, which is today the leading orchestration framework for containers. And it's successful in part because of a huge open source community, but more than anything else, I think what makes it successful is it was designed originally by people from Google who really understand applications at scale and how to run and manage them. Okay? So you can really see this in the constructs and abstractions that Kubernetes provides. And I'm going to go over a quick overview of what's most important about Kubernetes. So in Kubernetes, a cloud is called a cluster. It's made out of nodes. That's your machines. And the smallest unit of work that you can deploy on Kubernetes is called a pod. Think of a pod as a wrapper around one or more containers. You typically create and manage pods using something called a deployment. Think of it as a robot, which you can declare how to create pods, meaning what Docker image to use, what parameters to pass, how to configure them, and more importantly, how many replicas of a particular pod should be created for a particular service tier. And deployments also help with application upgrades. And then finally, pods would be pretty useless without the ability to accept traffic. So that's why we have services. A service lets you declare a selection of pods and then receive requests at a well-known DNS name and then load balance those requests across those pods for you. And when you create a service, it automatically registers itself with DNS so that it's discoverable. Okay? So you can see that with these concepts and constructs, Kubernetes makes it really easy and simple to deploy applications at scale, make them discoverable, and then manage them. So it's very powerful. So it's very good at babysitting applications, but then you might ask, if you want to deploy Kubernetes yourself, who's going to babysit Kubernetes itself, right? So this is where you may encounter some challenges, because Kubernetes is a complex stack consisting of dozens, if not hundreds, of different components, layers, optional add-ons, plugins. And so it can be a little overwhelming to get it right and configured and running properly. And also something we've learned from many customers is they don't just want to create one big cluster. Many customers want to create many clusters for different purposes or different teams. And also they want to create some on bare metal servers in their private data center and some in the cloud, like on AWS, and then manage everything in a unified way. And none of the existing solutions really help with that. There's also the question of high availability. How do you make Kubernetes clusters resilient to failure? There are recipes that you can read on the web, but it's not something that is easy. And what we've learned is things can break and will break, okay? Especially when you have a lot of moving parts. When a subcomponent fails, it can have ramifications on the rest of the stack, and the failures are sometimes not obvious to troubleshoot. And finally, upgrades. Kubernetes and its dependencies like Docker, they evolve at a really rapid rate, and there's always bug fixes and new releases several times per year. So it becomes a challenge to keep the entire stack up to date while not affecting application uptime. Okay? So because of all of those challenges, we thought about what is the best way to approach Kubernetes and running and operating it. And that is why we decided to offer Platform9 Managed Kubernetes, because we've learned that operating a cloud is hard. So we want to take away the complexity of running Kubernetes, and that is why PMK is offered as a SaaS service. So it makes it really easy for someone to sign up for an account and get started very quickly. PMK allows you to deploy one or more Kubernetes clusters on the infrastructure and operating systems of your choice. And that infrastructure can include bare metal servers in your private data center or cloud accounts like AWS. And then it lets you manage everything in a very unified way with our user interface. And here's one example of a screenshot of our user interface. It lets you manage your workloads, but also things like policies, users, and access control, and multiple clusters as well. So one thing to keep in mind is we don't stop at just deployment, right? The hard part is once the clusters are deployed, how to operate and keep them healthy. So the way we do this is PMK deploys your typical Kubernetes stack, and that is composed of a control plane and a data plane. The control plane runs the master nodes and this thing called the etcd cluster, which stores the state that is persisted by Kubernetes. And then at the next layer, the data plane is composed of worker nodes, and that's where Docker runs, that's where your workloads run, and so the data plane is critical. So the way we manage everything is Platform9 inserts an agent, okay, so that it can control all aspects of installation, configuration, HA, and we're going to talk about HA a little later. Upgrades is a key piece of this. Upgrading the Kubernetes control plane is actually relatively easy. What's hard is the data plane, because it runs things like the kubelet, the Docker engine, maybe some storage and network drivers. And so updating the data plane without affecting your workloads is something that is challenging, and we handle that, and I'm going to cover that in the demo. And last but not least, monitoring, okay? So these agents continually send health data to the management plane and to our monitoring system. And some people argue that monitoring is our secret sauce. And it's called Whistle, and it's been something we've been building and perfecting over many years. This is an example of an internal Whistle dashboard that our support team uses. Whistle in real time will consume health data, and it runs a bunch of algorithms that detect but also predict certain types of failures, and it raises alerts, and it's integrated into our support process. This next screenshot also shows Whistle monitoring vital statistics on customer systems, including CPU average and memory. So to summarize, Platform9 Managed Kubernetes tries to take away all the complexity from deploying and operating Kubernetes clusters. And it does that so that customers can focus on their applications and their own business. So with that, I'd love to switch over to the demo. What I'm going to show is I'm going to give a quick tour of the UI, and then I'm going to focus on upgrade of the data plane of Kubernetes while not affecting application availability. So let me start the screen share. Okay, so this is our user interface. We are in the clusters view, and here what I'm showing is two clusters. LEB Cluster 5 is a Kubernetes cluster that was deployed to AWS, and it has 3 master nodes and 1 worker node. And then Local 1 is something that we deployed to our private servers in our data center. So that's bare metal machines. And this one currently has 1 master node and 2 workers. Okay. There are also some useful links here for a particular cluster. So for example, if you click on dashboard, it'll bring up the UI for that particular cluster. So you can see resources such as services and pods. Okay. So how easy is it to deploy a new cluster to AWS, for example? The way you would do that is register something called a cloud provider account. Basically, you give it a name, and you enter your API access keys for the AWS account. And I've already done that with Hybrid Dev here. Then once you have that, you just go to Clusters and say Add Cluster. You select your cloud provider, and then the region. You select the availability zones to use, and we always recommend using all availability zones for that region. And the reason is PMK will spread the Kubernetes control plane across the availability zones so that if you have a node or even the loss of an entire zone, your cluster will keep running. And then the rest of these parameters is pretty straightforward. The number of worker nodes determines your cluster size. Okay? When you start deployment, it typically takes 5 to 10 minutes to finish. And we're going to publish some videos on our YouTube channel describing that process in more detail. I'm going to focus now on the second cluster, which is Local 1. So creating a bare metal cluster is also very easy, but it's a slightly different process. You first create a cluster, and it starts out empty, and then you add compute to it by attaching nodes. Okay? And the way you attach a node is you need to have a machine running Linux, and then download an installer that we have for supported operating systems, and that includes Ubuntu or various flavors of Enterprise Linux. So you just need to install that package on your Linux machine. It automatically starts our Platform9 agent, which then phones home to the management plane, and your node will then appear on this list. And in here, I have an example of a node with an IP address ending in 97. It was just recently registered, and you can see that it doesn't belong to any cluster yet. Okay? So we're going to add this node to local 1. Okay. So we're adding compute capacity to our Kubernetes cluster. Let me switch to this view here. So I'm going to show some CLI tools. Let's see. I have a little bash script running here that continually reports the number of worker nodes belonging to the local 1 cluster. And you can see that right now it has 2 worker nodes, 95 and 96. So if all goes well, we should see 97 appearing at some point. Okay, there it is, just appeared. Let me also show you PMK. So PMK is a CLI command tool utility that allows you to access the Platform9 management plane. So here you can list all your clusters, you can list your nodes, and perform operations like attach. Now, when you want to talk to a particular Kubernetes cluster, you use a different tool, and that's called kubectl. Okay? So kubectl here is configured to talk to local 1. So if I say get nodes, it'll say I have 1 master node and 3 workers. Okay? So with that, I'm ready to move on to, I think, the most important part of the demo. So imagine that we have a Kubernetes bug fix or a major new version or a new release of Docker Engine, and we now need to upgrade the data plane, right? And this is hard. How do we do this and not disrupt applications that are running? So for this example, I'm going to use an example program that I published on GitHub, so you're free to check it out and try it yourself. What this application simulates is, think of an embedded device that has very few resources, and in particular, it doesn't have a system clock. So the only way it can keep current time is by sending requests to a time server. Okay? So here, we've got this time server wired to a Kubernetes service of the same name called time server. And right now, there's nothing, the service is not running, so the application cannot get the current time. So the first thing we're going to do is deploy a YAML file for the service. Okay, and the YAML file can be found here. And the service still appears down because remember that a Kubernetes service, all it does is load balance requests to pods, but we don't have any pods yet. So I'm going to create a deployment. And the deployment specifies 1 replica of the time server application. And you see that Kubernetes just created 1 pod, and now the application is up, okay, because there's 1 pod responding. And each color here, and there's only 1 color for now, will represent a unique pod. So what happens if you decide to kill that pod? The service goes down, right? But remember that a deployment is a smart robot that will notice that you specified 1 replica and now there's 0, so it will automatically create a new one for you. So we should see new requests forwarded to the new pod. Yes, this is the new pod, and it should be coming soon. There you go. Let me just refresh this to give it a nice color. So this means that Kubernetes gives you this for free. So even if you have a legacy application that was not designed to scale, just by wrapping it into a pod and then using a deployment, you get free high availability, right? Now, of course, it's not continuous HA because we had some service disruption. So to get true continuous HA, the way you do that is you create more pods by scaling the deployment up to 3 pods in this case. Okay? And I'm going to start another script which shows you where pods are running. So now you can see that we have 3 pods, and each one is running on a different worker node, 95, 96, and 97. And down here, you're going to start seeing 2 new colors for a total of 3 unique colors. Okay. So now we're ready to perform an upgrade of the data plane. And this is a PMK responsibility. So what PMK is going to do, it's going to do something called a rolling upgrade of the worker node. And what that means is it's going to start with the first node, which is 95, and it's going to do a graceful shutdown of that node. And down here, you're going to see 95 entering the scheduling disabled state. And what happens now is we're going to lose the pod that was running on 95. So we only have 2 pods running. But again, the deployment is smart, so it's going to create a new pod to satisfy the 3 replicas requirement. So we should see a new pod running on 96. So now 96, that node is hosting 2 pods. And down here, the service is still up, and we should see a total of 3 colors again. So essentially, again, what we're doing, yes, so there's 3 colors. We're coordinating, PMK is coordinating with Kubernetes to perform a very orderly upgrade of the entire data plane without application downtime. So an application that can take advantage of multiple pods for availability will include the most important part of the demo. Let me go back to screen. Okay, so I hope to have given you a pretty good overview of what Platform9 Managed Kubernetes does. For more information, visit our website, and there's a nice white paper to read there. And more importantly, we have a sandbox application, so you can actually go and explore the product yourself in real time. And I think it's a good time to take questions.
Yeah, very cool presentation, Bich. Very cool stuff, and I appreciate the background on Kubernetes because I know a lot of the audience is probably like myself and is just kind of getting started in containers. So we talked, you talked a lot about containers and Kubernetes. Kind of what are the requirements for that? How would someone get started with that?
So it depends on whether they want to deploy to a cloud like AWS or they want their own machines. If your question is about their own private servers, then the only requirement is for it to run one of our supported Linux distributions. And then the machines just need networking and storage, local storage. So it's not much in terms of requirements.
Okay. And what's the difference between Platform9's Kubernetes and the general version or other distributions of Kubernetes?
Yeah, that's a good question, and I tried to allude to some of that during the presentation. Most other solutions that we know of, they focus on initial deployment, whereas we try to handle the entire life cycle, including ongoing maintenance, troubleshooting, and most importantly, upgrades.
Okay. And if someone has, say, a vSphere environment today, is it true they could add Kubernetes on top of that? And would Platform9 manage both Kubernetes and their vSphere infrastructure?
Yes, one way to do that is there's two ways to do that. One is to treat vSphere as another cloud provider, okay? And we are architected for that. We don't currently support vSphere as a cloud provider, but that's something that should be fairly straightforward to do. In which case we would be able to deploy to that just like we deploy on AWS. Another approach is to create a bunch of virtual machines on VMware and then treat them as physical machines by installing Linux. And then you can download the Platform9 agent, and then Platform9 at that point will just think that they're bare metal machines. It won't be able to tell the difference. So that's another way you can go about doing that.
Okay. And if someone, say they aren't ready for containers at this point, but they just want a private cloud, that's something that Platform9 can provide as well, really, with your OpenStack as a service. Is that true?
Exactly. And they can start with OpenStack, and they can transition to Kubernetes or run both side by side. That is something we support.
Okay, nice. So how do you all handle the controls, the access, and the collaboration if you have multiple teams as shops that do containers typically do?
Yeah, that's a great question, and every shop is different. Some customers like to create one big cluster and then divide it into pieces for their various organizations. Kubernetes and PMK allows you to do that. For example, Kubernetes has something called namespaces that can be used to isolate different teams. Another approach that other customers like is just to create one cluster per team, and we support both models.
Okay. And if someone is using, say, public cloud services today, does your Kubernetes as a service, it works with on-premises, say, vSphere, as well as public cloud infrastructures? Is that
exactly
true?
Yes, and you can manage everything from a single pane of glass. And Kubernetes also has powerful features called something called federation that allows you to connect these different clusters running on different clouds for various use cases like cloud bursting or high availability.
Excellent. And I mean, again, the main benefit of Platform9 is there's no, whether you're looking at OpenStack as a service or Kubernetes as a service, there's no deployment or ongoing maintenance of that OpenStack or Kubernetes infrastructure. Platform9 takes care of all that. Am I understanding that right?
That's right. It's a service. And we try to make most things just a click away. And the service is backed by our great support team who has had years of experience running these clouds. So yes, that is exactly what we provide.
Excellent. And then I guess probably the last question we have time for, and that is, in the sandbox, what would someone find in there?
They should be able to log in and register, for example, an AWS, their own AWS cloud provider account, and they can start deploying Kubernetes clusters and managing them on their own instances in their own EC2 account, for example.
Very cool. Very cool. I'll have to check that out myself. Great demonstration today, Bich. I really appreciate your time, and I know the audience really appreciates the education on Kubernetes and containers and how Platform9 can make all of that easier.
Thank you.